Welcome to the Reteach for Ionic charge. So, first let's talk about how something becomes an ion and why it becomes an ion. This right here is a beryllium atom. It has 4 protons. It has 4 electrons. That means that it has 4 positives and 4 negatives. Let's ignore the nucleus for a moment. Let's focus on the electrons. So I start with 2 electrons that I need to put somewhere. They have to go in the first shell. But there's only 2 spots there. So the remaining 2 electrons that I have, because I got 4, remember, gotta go into the second shell. But the second shell has 8 spots. Only 2 of them are filled. 6 are unfilled. This makes this atom unstable. And it's not particularly happy as it is, because it wants to have that outside shell, called a valence shell, be filled. So it does not want only 2 valence electrons. It wants 8 valence electrons. All right, well, this is a problem. It wants a full valence shell. There are 2 methods it can use to get it. Because this one is only partially filled, it could either find 6 more, or, to move my face around a little bit, it could just lose the 2 it has. Because if it loses the 2 it has, the second orbital just goes away entirely. The second shell is gone. If the second shell is gone, now the first shell is the valence shell. But it's full. So it could do 6 steps to gain 6 electrons, or it could do 2 steps to lose 2 electrons. That's way easier. So goodbye second shell. Goodbye 2 electrons. Now we have a full valence shell. Look at that. But only 2 electrons now. 4 protons and 2 electrons. So back when it had, its 4 electrons, 1, 2, 3, and 4 protons, and 1, 2, 3, and 4 electrons, the charge was 0, because every positive is canceled out by a negative. But now that it's an ion, has 4 protons and only 2 electrons. So 1, 2, 3, 4 protons. We can't change that, but we've lost 2 electrons. We now only have 2. But we have now 2 more protons than we do electrons. So we have more protons, which means our charge is positive. We have 2 more protons, which means the charge is positive 2. We lost electrons, so our charge is positive. Because we have 2 more protons, the charge is positive for protons 2. All right, so now let's look at this. Nitrogen atom. Okay, it has 7 electrons. The first 2 go in the first shell as before. Then I got 7, which means I have 5 more I got to do something with. So I got to put them in the second shell. But the second shell has 8 spots, remember, which means it has 3 that are unfilled. Okay, so what is it going to do? It wants to be stable. It wants to have a full valence shell. So is it going to do it by losing the 5 it has, or just by gaining 3 more? It's going to do whichever is easiest. All right, so first let's look at what its original charge was. If you have 7 protons and 7 electrons, they cancel out, give you a charge of 0. Not a big deal. 7 protons, 7 electrons? That means I have 3 empty spots. The easiest way to get a full valence shell is not to lose 5, but to gain 3. But now, look at this. We have 3 more electrons than protons. Since we have more electrons, our charge is negative. Since it's 3 more electrons, the charge is negative 3. All right, so what's the trend then? When we're talking about the trend on the periodic table, well, we know that atoms want a full valence shell. They'll do that either by losing some becoming a positive ion, or gaining some, becoming a negative ion. Okay, we know that all elements in a column, also called a family or a group, have the same number of valence electrons. So they're all going to do the same thing, gain or lose. So they're all going to end up with the same charge when they become an ion. That's called the ionic charge. The charge you would have if you were an ion is the ionic charge. All right, so what does that look like? Well, here I have 1 valence electron, here I have 2, and 3, and 4, 5, and 6, and 7, and 8 valence electrons. All right, well, that first column, 1 valence electron, it's really easy to lose that 1, becoming a positive 1 ion. Second column, it only has 2, so it's going to lose 2 to become a positive 2 ion. 3, it's going to lose 3 to become a positive 3 ion. 4, it could lose 4 or gain 4, equally difficult. So it could do either, which means it doesn't do either. Here, though, that nitrogen, I now have 3 spots missing. So I could lose all 5. That's way more work than gaining 3. So that column becomes a negative 3 ion. 2 empty spots, negative 2 ion. 1 empty spot becomes a negative 1 ion. No empty spots, doesn't become an ion. So, just some quick checks for understanding. Please find Sr, strontium. What is its ionic charge? Let's see if you're right. Positive 2. What about aluminum? Positive 3. What about oxygen? Negative 2. These problems are real easy if you have a periodic table that is annotated, which is I've asked you to do. All right, boron. Where's boron? Oh, there it is. It has a negative 1 charge. All right, there we go. That is the trend for ionic charge on the periodic table. Good work.